Inside modern EV batteries, engineers are quietly replacing traditional thick cables with flat metal conductors called busbars. But this changes far more than just appearance. It affects space, cooling, manufacturing, and performance. So why are EVs moving toward busbars? Traditional high-voltage cables work well, but inside a tightly packed EV battery, they consume valuable space. And in battery engineering, space directly affects energy capacity. As current increases, heat becomes another challenge, especially during fast charging and high-power acceleration. Flexible cables also complicate manufacturing. Routing hundreds of wires precisely is difficult to automate. A busbar is a rigid conductor designed to carry large amounts of current, creating short, direct, low-resistance power paths. Instead of routing electricity through bulky round cables, busbars distribute power efficiently across the battery pack. Flat busbars save space, allowing engineers to fit more battery cells inside the same pack. Their flat surfaces also help transfer heat more effectively, improving thermal management. And unlike flexible cables, robots can precisely weld busbars at high speed, making manufacturing faster and more consistent. Copper carries more current with lower resistance, but it's also heavier and more expensive. Aluminum is lighter and much cheaper. So many EVs now combine both materials, because engineering is rarely about perfection. It's about trade-offs. As EVs move toward higher voltages, faster charging, and more compact architectures, busbar engineering becomes even more critical. But busbars can't simply be exposed metal. Inside EVs carrying hundreds of volts, insulation becomes critical. Special dielectric layers prevent arcing, leakage, and short circuits. Many EVs now use laminated busbars, multiple conductive layers stacked together with insulation between them. This reduces electrical noise and improves power stability at high current. At high switching speeds, current creates electromagnetic interference. Poor busbar design increases inductance, causing voltage spikes and efficiency losses. So geometry matters just as much as material. Even surface coatings matter. Copper busbars are often coated with tin or nickel to reduce corrosion, improve durability, and maintain reliable electrical connections. And spacing between conductors is carefully controlled, because at high voltage, electricity can jump through air or travel across contaminated surfaces. That's why creepage and clearance rules are critical in EV design. Designing a busbar isn't just choosing copper. Engineers first calculate how much current the busbar must carry. That determines the required cross-sectional area. Current density equals current divided by conductor area. Too small, and heat rises rapidly. Too large, and the system becomes heavy and expensive. Busbars also generate power loss, because every conductor has resistance. Higher current means exponentially higher heat generation. Temperature rise becomes one of the biggest design constraints, because excessive heat reduces efficiency and damages insulation over time. Even bolts and fasteners matter. Loose connections increase contact resistance, and that creates dangerous localized heating. That's why EV busbar joints are carefully torque-controlled during assembly, because one poor connection can create thermal runaway conditions. Inside every EV, power distribution affects efficiency, heat, safety, and performance. And behind those simple metal bars is a massive engineering decision. Subscribe for more EV engineering.